It's racing faster than almost anything else in our skies, 135,000 miles per hour. And yet, impossibly, it seems to be fighting the sun itself. A plume of gas and dust, not trailing away like a comet's banner in the solar wind, but firing straight into the glare, as though the object is resisting the pull of our star. When Hubble caught the first clear image of this anomaly, the data was so outrageous that many scientists thought the instruments were misaligned. But it wasn't an error. It was real. This is 3I Atlas, only the third interstellar visitor humanity has ever detected, and its behavior has torn a hole in the rulebook of astrophysics. Welcome to Velocity of Comets. I'm inviting you tonight to stand with me at the crossroads of mystery and discovery. Because what NASA has now admitted about 3I Atlas doesn't just challenge our understanding of comets. It forces us to confront a larger, more unsettling possibility, that this object may not be entirely natural. The story began on July 1, 2025, when a telescope in Chile, part of NASA's Atlas survey program, noticed a faint point of light cutting across the stars. At first, it looked like just another distant comet, but then its velocity was measured, more than 130,000 miles per hour. That's too fast to belong to our solar system. Instantly, astronomers knew it was something rare, an interstellar object born in another star system now passing through ours. Only twice before had humanity ever spotted such visitors, 1I Oumuamua in 2017 and 2I Borisov in 2019. But unlike Borisov, which behaved much like an ordinary comet, or Oumuamua, which baffled astronomers with its acceleration, but showed no visible tail, Atlas was different from the start. Its trajectory was too clean, too straight. Imagine tossing a ball into a storm and watching it fly in a perfect line while everything else around it whirls chaotically. That was Atlas. Models that normally describe cometary motion broke down. Probability estimates suggested the chances of its orbit aligning so closely with Earth's, tilted by just 5 degrees, were less than 1 in 500. And its course wasn't random. It was set to skim past Mars, then Venus, then Jupiter. The odds of such a scenic tour were closer to 1 in 20,000. Coincidence? Perhaps. But then came the discovery that turned whispers of curiosity into shockwaves of disbelief. As Hubble and Gemini South sharpened their gaze, they revealed the impossible, a sunward-pointing plume. Instead of trailing behind, away from solar radiation, Atlas's tail aimed directly into it. It was as if a flag on a windy day decided to point into the gust instead of with it. Nothing in the textbooks allows this. Comets are supposed to lose material as the sun heats their icy nuclei, producing jets of vapor that always flow away from the star. Yet Atlas appeared to be doing the opposite, emitting dust and gas in a focused jet toward the sun. It wasn't just a flicker. It wasn't a momentary anomaly. Observations showed it to be steady, consistent, relentless. A comet behaving like an engine. Behind the scenes, scientists panicked. In private emails, in conference calls, in hurried meetings at NASA, ESA, and MIT, the tone shifted from curiosity to alarm. Because what they were seeing wasn't merely odd, it was impossible. Astrometric tracking soon confirmed it. Atlas wasn't following the simple curve dictated by gravity. Something was pushing it. A gentle but sustained acceleration of about 4 × 10⁻⁷ meters per second squared. That's tiny, yes, but over weeks it was enough to shift the object's position by thousands of miles. To put that into human terms, the thrust was comparable to the ion engines we use on spacecraft, like NASA's Dawn mission or ESA's BepiColombo. But where did the thrust come from? If it was simple sublimation, the boiling off of ices heated by the sun, the comet would need to be venting 10 times more material than was visible. The numbers didn't balance. The physics didn't balance. And then the James Webb Space Telescope took its turn. Its instruments, capable of breaking light into its chemical components, gave us the object's spectral fingerprint. What it revealed only deepened the riddle. Instead of the usual mix of water and carbon dioxide found in most comets, Atlas showed an astonishing imbalance: 8 parts carbon dioxide for every 1 part water. And more baffling still, Webb detected atomic nickel in the surrounding gas, but no iron. Normally, nickel and iron are inseparable. They're forged together in the cores of exploding stars, paired in cosmic history like twins. To find nickel without iron was like discovering a single footprint in an untouched desert. Was this a comet born in some alien stellar nursery, unlike anything we know? Or was the composition deliberate, engineered, as if the plume itself were designed to behave in ways we'd notice? For many astronomers, the parallels with Oumuamua were impossible to ignore. That first interstellar visitor had also refused to obey gravity, displaying a non-gravitational acceleration that couldn't be fully explained. Theories ranged from outgassing to hydrogen ice, but none fit perfectly. Harvard astrophysicist Avi Loeb famously suggested it could be an artificial light sail, a thin manufactured structure pushed by starlight. The idea was ridiculed by many, but Oumuamua left the field with an unresolved wound. No natural model could entirely close the case. And now, Atlas arrives like Oumuamua's louder, bolder cousin. Where the first was silent, the second blazes with an impossible jet. Where the first concealed its composition, the second flaunts its bizarre chemistry. 2 anomalies, less than a decade apart, both breaking the rules of motion, both hinting at something we can't easily explain. Patterns matter, and patterns raise the stakes. If Atlas is natural, then our understanding of comets, of planetary systems, of the chemistry of star formation is incomplete in ways more dramatic than we ever realized. But if it's not natural, if that plume is propulsion, if that nickel signature is intentional, then we may be looking at something far more profound. And the timing makes the mystery even sharper. On October 30th, 2025, Atlas will reach perihelion, its closest pass to the Sun. It's the moment when its propulsion, or whatever force is driving it, will face the greatest stress. But just then, from Earth's perspective, Atlas will slip behind the Sun. For weeks, in an event called solar conjunction, every telescope we have, Hubble, Webb, ground-based observatories, even radio networks, will be blinded by solar glare. We'll lose sight of the object completely, right when it matters most. Think about that. If Atlas were to make a course correction, if it were to fire its engines, change trajectory, slow down into orbit, that would be the moment to do it. And we would see nothing. Coincidence? Or the perfect cosmic cover? We cannot yet answer. What we can say is this: every day, every observation makes Atlas stranger. A comet shouldn't do this. A natural body shouldn't do this. And yet it does. For now, the world waits. Astronomers run simulations. Space agencies quietly debate contingency plans. SpaceX mission planners eye their charts with growing unease. And in universities, in observatories, in late-night conversations, the same question burns. What if Atlas is not just a rock with ice, but a message, a machine, a test? Whatever it is, Atlas is rewriting the script of interstellar exploration. And we are here to witness it. Welcome to Velocity of Comets. Stay with me on this journey. Because when Atlas emerges from behind the Sun, it may not just be a comet anymore. It may be the first sign we're not alone. So subscribe, share, and walk this path with me, not just as viewers, but as companions in humanity's search for meaning in the stars. When I think about 3i Atlas, I can't shake the feeling that we are no longer just observing a comet. We are deciphering a riddle. And every new data set, instead of solving the puzzle, only deepens the mystery. Let's start with what James Webb revealed. The telescope's near-infrared spectrograph and mid-infrared instrument can read the faintest whispers of light, converting them into chemical fingerprints. And when Webb analyzed the glow of Atlas's coma, the halo of gas and dust surrounding its nucleus, it returned a recipe that almost felt like a message. 8 parts carbon dioxide for every 1 part water. That ratio is unheard of in our solar system. Comets here are usually balanced, sometimes with a little more water, sometimes with a little more CO2, but nothing like this. And then came the real bombshell. Atomic nickel in abundance, but no iron. Normally, nickel and iron are twins. They condense together in stellar explosions, fuse together in planetary cores. To find one without the other is like seeing lightning with no thunder. It should not happen. NASA scientists ran models. ESA cross-checked. MIT astrophysicists pored over every variable. Could Atlas have formed in an environment where iron never condensed? Could there be unknown chemistry at work, producing nickel vapor while hiding the iron? None of the explanations fit. And yet, the anomalies didn't stop there. The Deep Space Network, the global web of radio antennas we use to track spacecraft and deep space signals, began picking up something strange. As Atlas rotated, its plume shifted in brightness, waxing and waning like a cosmic heartbeat. That much could be natural, but superimposed on that rhythm were faint electromagnetic spikes, tiny, sharp bursts of energy. At first, most thought it was noise, cosmic rays, background interference, maybe even terrestrial contamination. But when independent observatories in Spain and Australia confirmed the same intervals, the pattern could no longer be ignored. The spikes repeated. They aligned with prime number intervals. They showed harmonic ratios. In other words, they carried structure. The kind of structure that natural processes rarely produce. And this is where the debate exploded. One camp argued it was still natural. Perhaps the rhythmic pulses came from geysers of gas erupting from the nucleus, in sync with its spin, like Old Faithful in space. Maybe exotic dust grains charged by solar radiation were interacting with the magnetic field in unexpected ways, producing bursts that mimicked structure. Nature, after all, is the greatest trickster. We've been surprised before, by pulsars that first looked like alien beacons, by quasars that seemed impossible until we understood black holes. The second camp leaned toward unknown physics. Maybe carbon dioxide under extreme interstellar freeze and thaw cycles can behave in ways we've never observed. Maybe heavy-grain jets interacting with the solar wind produce electromagnetic noise that just happens to look structured. This explanation saves us from the alien hypothesis, but it requires a leap into phenomena we've never modeled. And then there was the third camp, the one whispered in corridors, spoken cautiously at conferences, admitted with hesitation even among trusted colleagues. Artificial. If the plume is not just venting, but thrust, then Atlas is maneuvering. If the EM pulses are not random, but coded, then Atlas is transmitting. Suddenly, this stops being a comet and starts being a probe. A Bracewell probe, perhaps. The theoretical autonomous machine proposed in the 1960s, designed to seek out young civilizations and deliver knowledge. Or maybe something else, a long dormant relic from a civilization long gone, its systems flickering to life as it passes a new star. And here's the detail that chills me most. When teams filtered the EM pulses, some patterns aligned with prime numbers 2, 3, 5, 7, 11. Basic, undeniable mathematics. The simplest way to prove intelligence. Any species capable of detecting interstellar objects and decoding EM signals would recognize primes. It was almost as if Atlas were running a test. Are you listening? Can you understand? But what comes after recognition? That's where speculation becomes dangerous. Some researchers suggest that the signal may contain layers, like an onion of information. The outer layer is simple structure, enough to get our attention. Beneath it, perhaps, lies data encoded in ratios, harmonics, or even modulation of the plume itself. We may be seeing only the surface of a much deeper transmission, one we don't yet know how to decode. Others fear it may not be a message at all, but a warning. If Atlas is shedding carbon dioxide and nickel deliberately, perhaps it is not propulsion or communication. It's debris. A dying system venting its last reserves. Or worse, the remains of a conflict drifting across the stars. A relic of destruction, not creation. And then there is timing. The object will reach perihelion on October 30th, 2025. At that moment, the Sun's gravity, radiation, and heat will bear down at maximum intensity. And yet, just then, Atlas will disappear behind the Sun from Earth's perspective. We call this a solar conjunction, a period when the Sun blinds our instruments, leaving us unable to observe. It's hard to overstate how suspicious the timing feels. If you wanted to perform a maneuver unseen, perihelion would be perfect. That's when a small change in velocity, just a fraction of a meter per second, has the biggest impact on the future trajectory. A nudge then could sling Atlas into a stable orbit around the Sun, or into a carefully chosen path through the solar system, and we wouldn't know until weeks later, when it re-emerges from the glare. This is where the tension spreads beyond science into engineering and planning. At NASA's Jet Propulsion Laboratory, trajectory specialists are quietly recalculating possible paths. At ESA, mission planners are considering whether probes could intercept Atlas if it changes course. And at SpaceX, where Starship test flights and Mars mission architecture are being laid out, engineers are asking uncomfortable questions. Could Atlas intersect Mars's orbit? Could its unpredictable thrust complicate planetary navigation? The probabilities are low, but they are not zero. And in spaceflight, even a whisper of uncertainty matters. Meanwhile, the public conversation grows louder, and not always rational. Some demand full disclosure, accusing agencies of hiding evidence of extraterrestrial technology. Others dismiss the whole story as overblown hype. Social networks fill with speculation, memes, debates, wild theories. The phrase, "science not silence," begins trending, as people demand transparency. But here is the quiet truth. Scientists are not hiding. They are struggling. The data is real. The mystery is real. But mysteries take time, and in the age of instant answers, patience feels like a conspiracy. As a reporter who has followed comets and cosmic anomalies for decades, I find myself torn between wonder and unease. We must resist the temptation to leap to conclusions. Yet we must also admit that what we are seeing with Atlas defies every expectation. Think of it this way. In less than 10 years, humanity has seen not one, but 2 interstellar objects with impossible behavior. Oumuamua, silent but accelerating. Atlas, noisy, flamboyant, flaunting its plume like an engine. The odds of encountering 2 such anomalies in such a short span are astronomical. Either the universe is far stranger than we thought, or these objects are far more common, and perhaps deliberately common. Which leads to a haunting question. If this is a message, what does it say? If it's a test, what happens when we pass or fail? And if it is a warning, what is it warning us about? As perihelion approaches, we stand on the edge of revelation. Maybe Atlas will emerge unchanged, and natural explanations will eventually catch up. Maybe it will reveal itself as something unprecedented, a true artificial probe. Or maybe it will vanish into mystery, leaving us only with echoes, spectral anomalies, EM pulses, trajectories that whisper of intent. But one thing is certain. Whatever happens next will redefine our place in the universe. Because Atlas is not just a comet. It is a story, a mirror, and perhaps a voice. And the real question is, are we ready to listen? The closer we come to perihelion, the more I feel a strange tension in the air. It's not just scientific. It's emotional, almost primal. Because with 3i Atlas, we are no longer asking, what is it? We are asking, what does it mean for us? Think of what we know already. A plume that defies physics firing into the solar wind. A sustained acceleration that mimics propulsion. A chemical signature dominated by carbon dioxide and lonely nickel without its eternal twin iron. Electromagnetic pulses, whispering in prime number intervals, like a teacher scribbling, "Do you understand?" on the blackboard of space. The more we observe, the more the questions multiply. Is this a comet? A probe? A relic? A warning? And if it is a warning, who or what is it warning us about? When I speak with colleagues across NASA, ESA, MIT, and the European Southern Observatory, I hear three schools of thought crystallizing. The first group clings to the natural explanation. They argue that 3i Atlas is simply extreme. A comet born in an alien system with exotic chemistry, carrying ices and metals in proportions we've never catalogued. Nature, they say, has a habit of humbling us. Remember pulsars? Discovered in the 1960s, they pulsed so regularly that astronomers jokingly labeled them LGM, for little green men. We now know they're rotating neutron stars. Perhaps Atlas is another such case, waiting to be explained. The second group suspects we're staring at physics we don't yet grasp. Maybe carbon dioxide under deep interstellar freeze behaves in ways that produce focused jets. Maybe dust grains interacting with solar radiation can channel energy in a way that mimics thrust. This view reassures us that we're not dealing with intelligence, but with ignorance, our ignorance. A gap in the models, nothing more. And then comes the third group, the quietest, but also the boldest. They see intention. They see structure. They see a comet that acts like a spacecraft, a plume that behaves like an engine, signals that echo mathematics. They see a probe. If that's true, then everything changes. Because a probe implies a sender, and a sender implies we are not alone. But here's where the story grows darker. If Atlas is artificial, what is its purpose? Some imagine a Bracewell probe, a theoretical machine proposed by scientist Ronald Bracewell, designed to seek out young civilizations, observe them, and perhaps initiate contact. In that scenario, Atlas may have been drifting for millennia, waiting for the right conditions to awaken. Its path past Mars, Venus, and Jupiter might have been deliberate, a final survey of our neighborhood before revealing itself. Others imagine something stranger. Perhaps the plume isn't propulsion, but dispersal. That chemical cocktail, CO2 and nickel, might not be waste, but payload. Maybe Atlas is seeding space, releasing engineered materials designed to alter planetary atmospheres. Could it be a terraforming device, designed not to travel, but to create? And then comes the most unsettling possibility. Perhaps it's not a messenger or a creator, but a survivor, a refugee. Its propulsion system not a tool, but a scar. Its strange composition not design, but wreckage. A fragment of a machine that once belonged to a civilization destroyed in some cosmic catastrophe. A galactic war, a stellar collapse, a dark forest event. The dark forest hypothesis, drawn from Liu Cixin's novel but discussed seriously in astrobiology circles, argues that the universe is silent because it is dangerous. Civilizations hide because to shout is to invite destruction. If that is true, then perhaps Atlas is not saying hello. Perhaps it is saying beware. Now, imagine the timing again. At the very moment of perihelion, October 30th, 2025, Atlas will vanish behind the Sun. For weeks, Webb, Hubble, ground-based observatories, all of them will be blinded. This is exactly when any maneuver would have maximum effect. A tiny thrust then could reshape its orbit, potentially settling Atlas into a stable path around the Sun. Hidden from us. Watching us. Coincidence? Perhaps. But the perfection of the timing gnaws at me. And this is where risk becomes real. NASA mission planners worry about close passes with Mars orbiters. ESA analysts track possible interactions with Venus. Even SpaceX engineers, planning Starship cargo flights to Mars, admit a degree of unease. An interstellar object with unpredictable thrust is not just an academic curiosity. It's a navigational hazard. But beyond the technical risks, like cultural ones, information about Atlas flows in two streams. The peer-reviewed, cautious reports released by agencies, and the whispers, the leaks, the classified memos. Rumors spread that NASA knows more than it admits. Has Webb already detected encoded data in the plume? Are the EM pulses being actively studied as signals? Scientists, bound by evidence, hesitate. But the public fills the silence with speculation. And here, society fractures. Some demand science, not silence, insisting that data must be shared in real time. Others call for caution, fearing premature claims of alien technology will trigger ridicule or panic. #Meta, Sex 0.05. Social media becomes a battlefield. News outlets chase headlines. The narrative slips beyond science into myth, into philosophy, into politics. And yet, beneath all of this noise, a profound truth emerges. Whether Atlas is natural or artificial, it teaches us the same lesson. Intelligence is fragile. Civilizations, even advanced ones, are not guaranteed survival. If Atlas is natural, it humbles us, reminding us how limited our models truly are. If Atlas is artificial, it warns us. We are not alone, but neither are we immortal. Intelligence can rise, shine, and vanish, leaving only relics drifting through the void. To look at Atlas is to see a mirror. It shows us what we might become, curiosity embodied or catastrophe memorialized. And as perihelion approaches, I feel the weight of history. This object, streaking across our sky, may change how humanity sees itself. When it emerges from behind the sun, we will know more. We may know everything, or we may be left with riddles forever unanswered. But either way, Atlas has already changed us. It has forced us to confront the possibility that the universe is not silent, but speaking, not random, but patterned, not empty, but inhabited. So we wait, we watch, we wonder, and we ask the hardest questions of all. If Atlas is a messenger, what is it saying? If it is a warning, do we have time to act? And if it is a relic, how long do we have before we join it? This is the story of 3I Atlas. It is not finished, it is only beginning. And so is our journey into the unknown. Stay with me. Stay with us, because the cosmos has begun a conversation, and humanity must decide how to answer.
The story of 3I Atlas is more than just the tale of a comet behaving strangely. It is the story of how the universe humbles us, surprises us, and invites us to look deeper. From the moment it was discovered in July 2025, streaking across the night at 135,000 miles per hour, it has refused to fit into the neat boxes of our science. A sunward plume that mimics propulsion. A chemistry dominated by carbon dioxide and lonely nickel. Electromagnetic pulses beating like a cosmic heart. Every observation adds another layer to the enigma. We may never know for certain what Atlas truly is. Perhaps it is a natural object, formed in a star system so alien to us that it challenges our assumptions about what comets can be. Perhaps it is an artifact, a probe, a messenger, or a refugee from a distant civilization. Or perhaps it is something in between. A natural body that carries with it an echo of intelligence, a hybrid of chance and intention. But whatever the truth, Atlas has already done something extraordinary. It has forced us to pause and reflect on our place in the cosmos. It has reminded us that our solar system is not isolated, that the galaxy is alive with travelers, and that we are part of a larger story written across billions of stars. And it has whispered a lesson that is as personal as it is cosmic. Intelligence is fragile, wonder is fleeting, and the only way to face the unknown is with curiosity and courage. As I reflect on this journey, I feel both small and deeply connected. Small, because the universe is vast beyond comprehension. Connected, because for the first time in history, humanity is watching together. Our eyes trained on a single visitor, our minds wrestling with a single question. Are we alone? Or are we being called to listen? So I leave you with this thought. 3I Atlas may vanish into the dark, but the questions it leaves behind will burn in us for generations. What do you think this interstellar traveler truly is? Subscribe so we can continue this cosmic journey together.